Hi everyone, I'm Mingfu Liang from Northwestern University, and here I will talk about my work balancing between forgetting and acquisition in incremental subpopulation learning. Subpopulations are widely exist in the real world. A racial category contains a large number of subpopulations which are semantically similar and share common racial characteristics to be in the same category, while they also have large difference in appearance, shape, context, and so on. Each subpopulation is also a distribution with sufficient variations. For example, cover thousands of distinct objects belonging to this subpopulation in nature. However, due to the racial complexity of a category in nature, it's hard to completely cover all the subpopulations during data collection. A recent study shows that existing state-of-the-art CNN architecture have very strong generalization on the test set of the learned distribution. However, for the unseen subpopulations, those state-of-the-art CNNs are hard to predict their class labels. This performance gap could be larger than 30%. Such a problem is called subpopulation shifting, and it largely hinders the test time performance of a learned model. Therefore, in the present work, we provide a first and comprehensive study of tackling the subpopulation shifting problem in an incremental learning manner. For example, incrementally learning to recognize the unseen subpopulations of dog as dog without retaining the data of seen population, and we call this incremental subpopulation learning, shorted as ISL. The main problem of ISL is to balance the seen population forgetting and unseen subpopulation acquisition. Existing words in incremental learning optimize the acquisition and forgetting jointly, where the control of the forgetting is based on predefined hyperparameters. However, there's no explicit modeling of the relationship between acquisition and forgetting before the incremental learning, and there's no guarantee that one can obtain a great balance in the long run. Therefore, to tackle these challenges, we propose a novel two-stage learning framework as the new baseline for the ISL, where we disentangle the knowledge acquisition and forgetting alleviation into two stages. For the first stage, we progressively learn a new classifier using only the training data from unseen subpopulations without explicitly imposing any regularization on the forgetting. This is based on the functional gradient techniques from the generalized boosting theory. The feature extractor is frozen after the base step chaining and is shared during each incremental step. We leverage the margin enforced loss to enforce hard sample and hard class to have larger rates for classifier updating, such that we can enjoy efficient learning for the unseen subpopulations and mitigate forgetting simultaneously. In stage 2, we further achieve the balance between forgetting and acquisition by linearly combining the old and the new classifiers based on an addictive parameters alpha t. We design a new objective function based on the forgetting proxy estimation and acquisition measurement, where the former is to measure the relative distance distortion of the decision boundary using the class mean feature between the old and the new classifiers, while the latter is to assess the relative improvement of validation accuracy between the old and the new classifier on the unseen subpopulations. Then we search for the proper alpha t by optimizing the objective function. We conduct a first empirical exploration for the ISL based on the large-scale Greece datasets, which is tailored to study the subpopulation shifting problem. Our method can achieve better average top-one accuracy after learning from many new subpopulations than the existing methods. This shows that we could achieve a much better balance than acquisition and forgetting in the ISL by explicitly disentangling them into the two stages. For more details, please scan the QR code to access our GitHub reports and come to our poster 3551. Thank you so much for listening.